Well, in the previous video, we took a regular foregon, which is a four-sided regular polygon, which is a square. That's another name for a square. And we circumscribed it in a circle. We put this drew a circle that touches each one of the four corner points or vertex points of the square. We actually also did it with a regular six-sided figure in the previous video. Well, it turns out that if it's a regular polygon where they all have the same length side, all sides are equal length, a regular ingon can be inscribed in any circle just like this. So it doesn't have to be a four-sided, it could be a regular six-sided figure polygon, or a seven-sided, or 10-sided, or 100-sided. You can inscribe it into a circle. Now, the next theorem may not hold, actually wouldn't hold, I believe, at all in spherical geometry or hyperbolic geometry. So this certainly requires that we be in Euclidean geometry for this theorem. And you might remember this from high school. I'll call this theorem convex polygon. Well, what is the interior angle sum of a convex ingon? Well, let's see if we can figure it out before we write the formula here. This does not need to be a regular polygon, just convex. Here's a picture of a convex, and it's not regular. You can see this side is longer than this side, for example. Okay, so here is our convex hexagon or sixgon. What are the angles we're talking about? We're talking about the interior angles here. What do we get if we add up all 6 of the interior angles of a convex sixgon? Well, let's think about this. Let's go, we've got it drawn here. From one vertex, choose any one of them. Draw a segment to each of the other 5 vertices. So from here, I'll just pick this one. I've got one to here, I've got one to here, so I've got to draw one to here. I've got to draw to here. And I've got to draw to this one. So now, it doesn't matter which vertex you pick. I picked this one, and I drew 1, 2, 3, 4, 5. There are 5 line segments starting here, connecting to each one of the other vertex points, the corner points. Now we're going to add up the angles. Well, how does that help us? What is this angle plus 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 this angle? You're adding up all 6 interior angles. Well, notice that this little part of that angle plus this angle plus the measure of this little part right here, that's the interior angles of a triangle. Those are going to add up to 180. And then take this triangle. That takes care of this one, this, and this. Those add up to 180. And then we go to the next triangle and we do the same thing. That one plus that one plus that one. And then finally we get this triangle, this interior angle plus this interior plus this one. That adds up to 180 as well. And what did we get when we add up all of those angles of the triangles? We'll get exactly the same number as if we were adding up the 6 interior angles of this sixgon. It's just a different way of adding it up. And what is that number going to be in this case? Well, it's going to be 180 for each of the triangles. 1, 2, 3, 4. 180 times 4 is 720 degrees. Now, make a note. How many triangles did we have? We had 4 triangles in a 6-sided figure. 2 less than the number of sides, or 2 less than the number of vertex points. 6 sides 4 triangles. And here's where we'll get, so yeah, let's just write down what that formula would be in general. Oh yeah, we left it blank right here. 180 times what? Not n, but n minus 2. That's the formula to get the sum of all the interior angles of a convex polygon. N is the number of sides. Okay, I have a corollary to that to finish up this video. Each interior angle of a regular convex n-gon is going to have measure what? Well, this is not regular. This one isn't. But if it were, it might look something like this. This looks like a regular 6-sided polygon. If it's regular, it means all of these interior angles have the same measure. So how would you find the measure of each one of those interior angles? You simply take 180 times n minus 2, that's the sum of all of them, and then divide it by the number of angles. That's all there is to it. So it's going to be 180 times n minus 2 all over n. So you're just basically taking the average. You're dividing it by the number of angles, which happens to be the same as the number of vertex points. Okay, so here's another formula you need to remember. Each one of these angles in a regular convex n-gon has measure 180 times n minus 2 over n. Now let's take a look at exterior angles. So draw a convex hexagon. We've got it right here. Actually, I should have said, let's see. Nope, in this case, it does not need to be regular. Even though this looks like it's regular, that's perfectly fine. Draw a convex hexagon. We've got it. From each vertex, pi, so I is going to be 1, 2, 3, 4, 5, or 6. From each one of them, extend the side, so from 1 I to I plus 1, point 1 to point 2, extend that side like that. Now it's a ray P1, P2. We're going to do it each time, and we're going to label the new angles. So I will call this one angle 1. And then we're going to extend P2 to P3 into a ray like that. And I'll call that angle 2. Extend P3, P4 into a ray. We'll call that angle 3. Extend 4, 5 into a ray. And we'll call this newly created angle, where are we, 4. And then we got P5, P6. We've got a newly created angle here. We'll call it 5. And lastly, we'll call P5, P1. We'll call that angle 6. So we have 6 exterior angles. And we labeled them all 1, 2, 3, 4, 5, and 6. All right, well, what is the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 plus the measure of angle 5 plus the measure of angle 6? Well, that's going to be one nice fixed number. It's going to be 360. 360 degrees. Think of it like making 6 left turns and returning to your starting position or direction. Remember, I'm assuming we all know this, if you're standing somewhere and then you rotate yourself 360 degrees, then you're going to be facing the exact same direction, when you started. 360 degrees. You're making left turns all the way around till you're facing the same direction. So basically, in general, the sum of the measures of We could have gone clockwise or counterclockwise. I went counterclockwise. If we would have extended in the other direction, well, it would be like the mirror image of this. We would get the exact same answer. The sum of the measures of clockwise or counterclockwise exterior angles of a convex n-gon is, it doesn't even matter what n is, it's 360 degrees.